The duck appears to be blue. This is not a common color for ducks. However, there are some breeds of blue ducks. These are typically not as common as other duck breeds. It is more common for ducks to be brown, black, or white.
Are you sure?
What the quack? I was just talking about a blue duck, and now you're holding one. It looks like blue ducks are more common than I thought.
You make bath time lots of fun.
Welcome to Farenheit AI, Episode 8.
In the world of generative AI, a prompt is just a fancy name for the input text that you feed to your model. You can get one of these models to take on all sorts of different behaviors based on how you structure your prompt.
In Krita, I drew a family reunion tree with picture frames. As I was drawing, the AI started to generate images that matched the drawing. This is a practical prompting tool. I prompt the AI, I want a family reunion tree with frames, and then I give it the reference of the drawing so that it generates an image that matches my drawing for a t-shirt.
This art and science of figuring out the best prompt for your use case is called prompt design, and it often involves a lot of experimentation. Let's start with a free-form prompt. One way to design a prompt is to simply tell the model what you want. In other words, provide an instruction.
The duck at the beginning of this episode is an example from Google Gemini, a ChatGPT competitor. I asked Gemini if they could narrow the selection to cotton garments using a series of videos recommended about dye migration. Next, I compared what it responded to and what ChatGPT-4 responded to. Their responses were very similar. Gemini presented with a few issues. One of the advantages of Gemini is that it has extensions like Chrome and you can link it to YouTube and Google. It has a vast database of Google, so it should lead the AI market, yet currently ChatGPT-4 is leading. When I asked Gemini to expand on the videos it sent me, Gemini recommended a video about a little girl dying. Then it explained that the video was relevant to dye migration. Gemini seemed to be confused and creating a connection that wasn't there. Bard, the chatbot version of Gemini, currently uses Gemini Pro.
After being born with a rare condition, Bella was going in for her 24th surgery, but always keeps her spirits high, even telling her mom a joke on the way.
Knock, knock.
Who's there?
Bella.
Bella who?
We're in a Bella-vator.
Gemini Pro underperforms GPT-4 in most situations, but Gemini Ultra outperforms it on almost every single category. Most notably, it's the first model ever to outperform human experts on massive multitask language understanding, which is typically a multiple choice test over a wide array of subjects, kind of like the SATs but for AI. What's hella surprising though is that Gemini Ultra underperforms GPT-4 on the HelloSwag benchmark. It's designed to evaluate common sense natural language. It's a job that's really easy for humans to do and a very important benchmark because when an AI can't do this well, it doesn't feel very human-like. In GPT-4, I can write a vague prompt filled with typos, and somehow it almost always seems to know what I'm talking about. The fact that GPT-4 is doing so much better on HelloSwag is hella concerning to say the least.
It is important to understand that multimodal AIs are everywhere, and they are watching. Multimodal agents are AI systems that can understand and analyze data in multiple modalities using the right tools in their toolkit. This is an example of a multimodal AI recognizing people who are littering and fining individuals through their license plates for littering in public spaces.
Now, LLMs are particularly good at identifying and completing patterns. So in addition to writing an instruction, it can be helpful to add some examples and show the model what you want. That's where few-shot prompting comes in. In this approach, you provide the model with a few examples. By controlling the degree of randomness, you can get more unexpected and some might even say creative responses.
Back in Krita, using style adjustments, I made another family reunion drawing in a style a customer may provide. I fed the drawing into the AI, adjusted the AI so it matched closely, copied the new generation, and fed the new generation back into the AI as an example. Then I continued this evolution until we reached a family tree that matched the original drawing and was aesthetically pleasing. Next, I used Photoshop and generative AI to apply all the apples to the tree to match the customer desired number and painted them red. We ultimately got an excellent vector result matching the original customer idea.
It's important to note that adding instructions and a few examples tends to yield good results. But at the end of the day, there's currently no best way to write a prompt. Experimenting with prompts is a core part of being a generative AI developer. You'll want to try out different structures and formats and examples and really just see what works best for your use case and the specific model you're working with.
Next, I built an AI agent to interact with myself, the user, to create Photoshop scripts. In this case, I made a Photoshop script that will generate a complete setup environment for a full color simulated process separation. This script is my first step in developing an AI for manual separation. During the step, first, you run the script. It generates about 30 different channel options to choose your colors from. It also generates your underbase and your highlight white. At the same time, I am creating a Photoshop Color Separator AI agent assistant. This assistant is being fed all of the script listener generated scripts of the separations in the background as a knowledge base. The agent is fed video sources of separations that have been successfully printed. I am building an entire knowledge index base on real-life separation. So, when it's complete, if you are trying to figure out how to print something that's maybe got a difficult transition, or you need help selecting a color, or maybe you want to know what print order to use, you can ask the assistant. The intention is to incorporate mesh so that you can understand what mesh is best for the application, what types of flashes you're using, and so you can converse with this AI tool as though it were a press operator, a separator, a color specialist, a screen room operator. It's a total shop knowledge combined so that you can make the best choices for the separation as it goes out to the production floor. Later, you could combine the assistant with other agents in other departments and allow them to share knowledge across your factory. The agent could review a separation before entering the production floor. But the first step is to build a multi-knowledge-based agent. MIT has a Mini Cheetah, and it's moving at the highest speeds ever recorded for a robot. It can move across multiple terrains. MIT created the Cheetah using machine learning instead of human-controlled operations. Existing robot controllers are manually designed, which is very laborious. This new learning-based approach lets the robot adapt to unstable terrain like gravel. Previous non-learning systems have trouble in challenging situations where they may slide and need help finding their way over obstacles. As a learning robot, it's able to retain information and gain experience, and then it can address the terrain in the future. The system is able to adapt to changes in the robot itself, like a disabled leg, and it can compensate for that issue. If you translate this to screen printing, if you need to reduce screens or eliminate a flash, it's making a compensation. Running fast stresses a robot hardware to its limits, and it changes the hardware's dynamic. The learning robot adapts to this change. This enabled the Mini Cheetah to run as fast as 3.9 meters per second, the highest reported speed for a robot. And it's really creepy.
As a quick recap, the prompt is your text input that you pass to the model. Your prompt might look like an instruction, and maybe you add some examples. Then you send this text to the model to get it to take on the behavior that you want.
The following example is an AI chatbot. If you think about the assistant agent in separation that can analyze the separations and tell if something is wrong before it gets to press, imagine another connected agent that knows about the application possibilities of different vendors, for example. In this case, we use a fundamental example from stalls. If you have a shirt with a full color separation on the front and a left sleeve transfer, the agent would be familiar with stalls, replying with suggestions based on the separation colors and the type of fabric. Agents working in tandem to give you a recommendation. This episode explores the very first step in building multimodal, multi-knowledge-based agents. The chatbot example is connected to Stahl's website and any active links in Stahl's website. Next, I can add things like videos and blogs, all of which have educational aspects about transfers. And then you can ask it specific questions. I've asked the chatbot in the video to help me find a full-color digital transfer for hats. There is currently no product offering in that category. The agent is giving me all of the full-color options and links to the website to find them. Then I can look and see once I've linked into the site if there's any additional options. Here, we have identified the agent needs to be optimized, and it needs to be told what to do when there is no product offering. Optimizing comes after connecting to a large language model, choosing if you're going to use OpenAPI or Google, for example, setting the agent up, adding memory, make sure you can communicate with the agent, and then you fine-tune. Fine-tuning is like seeing in the dark. Here's an AI agent doing vehicle-to-vehicle and vehicle-to-human collision alerts. Now that I'm able to communicate with it, I need to teach it how to be more discerning and how to be better at the choices that it makes. This is what fine-tuning is doing. As you send an agent out into the dark, it's trying to discern what you're looking for, and as you fine-tune it, it's going to find whatever you need. There is no light. It's entirely dark, and the AI can anticipate and see what's happening around it.
What the quack?
It's the end of